Okay, so let's do some homework together. So if I look at number 37, it says to solve this triangle. When it says solve the right triangle, it means it wants me to find all of the sides and angles of that triangle. Really? Solve the triangle? So I guess in this case, I know that across from the 45 is 16, right? And since this is a 45/90, this must also be a 45, so that means this is also going to be 16. So really the last thing I have left is this side. So that means if I take a squared plus b squared, I'm going to get c squared. So it's 16 squared plus 16 squared equals c squared. So that means that 16 times 16 should be 256 if my brain is working. So 16 times 16, 256 plus 256. This early in the morning is 512. And so if I take the square root of 512, you're going to get that c is approximately 22.6. So this is approximately 22.6, approximately. If you want exact, it's the square root of 512. Right? And we have solved that triangle because I found all three angles and all three sides. 47. So it wants us to solve for x. So x is the entire bottom of that triangle. The way we're going to think about it is this green piece and this blue piece. So if I come over here, I've got this blue piece. This is 100. This over here is 30 degrees. And I want to know this little, I'll call it x1 because it's part. X is going to be equal to this blue x1 plus this green x2. Yes, so it's going to be x1 plus x2. It's going to be what x is. So then when I take this triangle over here, it's going to be 60 degrees. This is going to be 100. This little piece is x sub 2. So now I have two triangles that I need to find those small pieces. So opposite of the 30 is 100, and the adjacent to 30 is x1. So if I have opposite over adjacent, I know I'm looking at tangent. So tangent of 30 is 100 over x sub 1. So now that means if I multiply both sides by x1, so let me stop here for a second, make sure that makes sense. If I multiply both sides by x1, these cancel out over here. I get x1 times the tangent of 30 is equal to 100. In other words, x1 is equal to 100 divided by the tangent of 30. Whatever that turns out to be on your calculator. Let me get mine out, which of course I don't have easily accessible. So I'll just go into Google and I'll say 100 divided by the tangent of 30 degrees. And it tells me the 100 divided by the tangent of 30, and you have to be careful and tell it degrees, right? To make sure it's not in radians. I would say 30 degrees is approximately, so x1 is approximately 173.2. And so now I'm ready to do x2. And here I have an angle, but I have its opposite from it and adjacent to it. So that means I have opposite divided by adjacent, which again we know is still tangent. So tangent of theta is that. So it's the tangent of 60, and opposite is 100 divided by the adjacent, which is x sub 2. Right? Just like we did before, I'm going to multiply both sides by x sub 2, which is okay, because I know it's not equal to 0. So on the right, I get 100. On the left, I get x sub 2 times tan 60. Then you divide both sides by tan 60. So we get 100 divided by the tangent of, in this case, 60 degrees. And I get approximately 57.74, right? And both times I was trying to round to 2 digits to the right, okay? All right, so that means that my x is just 173.2 plus my x sub 2 is 57.74. So if I take 57.74 plus 173.2. Again, the approximation that we're going to get is, that squiggly equals, is 230.94. All right. So that is 37 and 47. Now we're on to 53. So if we look at 53, height of a building, so the elevation to the top of the Empire State Building. So we have some building, and we have some person down here, and they're laying on the ground to make our life easier. They look to the top of the building, and the angle of elevation is 11 degrees from where they're at. And they're a distance of 1 mile away. Using this information, find the height of the Empire State Building. So first thing we're going to do is introduce a variable. We're going to say h is the height of Empire State Building, and it's going to be in, let's say it's in feet, yes, because it would make sense to think of anything else other than feet. So that means this distance down here, we want to convert that to feet to make all our units match. So that's 5,280 feet, because we have that memorized because we're an adult. So if I've got an angle and I want to relate its opposite to its adjacent, I think, oh yeah, that's going to be the tangent. So I write down the tool before I use it, and then I go in and start filling stuff in, right? So it's the tangent of the angle 11 degrees is equal to, opposite is h, and the adjacent is 5,280 feet. So there you go. Now, right now, we're going to put a big old caution. Make sure that you are now in degree mode, because if you evaluate and you're not in degree mode before you finish out this problem, you will screw that up. So now we're going to multiply both sides by 5,280. That many feet, right? 5,280 feet. And we're going to get 5,280 feet times tangent of 11 degrees. And that's going to be our answer in feet. So I'm going to clear, and I'm going to say, go over here, it's going to be 5,280. Do you need a calculator? Yeah, here you go. It's 5,280, what times? Tangent of 11, and make sure that you're in degrees. So if you're typing this into Google, you just type 11 DEG. It knows what to do. It says that the height is approximately equal to 1026. It says, I'll say 1,026 feet, so 1,026 feet. Be interesting to see if you double check that online to see if that's right. So we know it's right in terms of the problem. Great, great. All right, so there's 53. Let's look at 56. 56, distance to sea, the top of a lighthouse. So here's our lighthouse, right? Here's this. Here's the water out here. Here's its light shining out that way so boats don't hit things. The angle of depression to a ship. So that means that we take the horizontal, which is this way, the angle of depression to a ship. So here's our little ship right here, yes? Right. There's our boat. So the angle of depression, which is this angle, is 23 degrees. If the lighthouse is 200 feet tall, it wants to know how far away is the ship from the base of the lighthouse. So we'll assume that the lighthouse is right on the water, okay? So what we're wanting to know is what is this distance, and we'll call it D. So D is the distance from the lighthouse to the boat, and we're going to say it's in feet. So anytime you introduce a new variable, say what it is in units. Okay, so there is the picture. So now I think we need to see what is the math in the picture. Well, since we're doing right triangle trig, I guess I should be able to pull out a right triangle. I think you can see this one in here. So I've got 200 here. This is going to be a nice right triangle. Well, since this is 23 and the horizontal to my straight up and down building is 90, then I guess the rest of this is going to be 90 minus 23, which is 67, right? So up here I've got 67 degrees, right? Or if it makes you happy, you can remember from trig, these are parallel lines cut by a transversal, and these are alternate interior. So that means that this one down here is also 23 degrees, whichever one makes you happy. Okay, so I've got this. So I'll just use what I've got right now. So for this angle, I've got its adjacent and its opposite is D. So if this is opposite of my angle and this is adjacent to my angle, then I know that I want opposite and adjacent to relate to an angle, and the trig function that does that is tangent. So with the way I have it drawn, it's tangent. If I had done this angle down here, it still would have ended up being tangent, right? But just from a different angle. So I've got the tangent of 67 degrees. Put yourself a note, you must be in degree mode. Tangent of 67, the opposite of this angle is D, and the adjacent to it is 200. So my distance, and that's 200 feet. So I multiply both sides by 200 feet. My feet cancel out, but I introduce feet over here. I get 200 times the tangent of 67 is approximately how many feet I have. And so, let's see, take 200 times the tangent, 200 times the tangent of 67 DEG degrees, DEG, and I'm going to get approximately 471 feet. So, boat is approximately 471 feet from lighthouse. So now I really answered their question. Good job. So that's 56. Now I'm doing 60. So let's look at 60. 60 is determine the distance. A woman is standing on a hill. So she's on a hill, and they give us this picture. They say, look, she's on a little grassy knoll. For you history folks. So she's on a grassy knoll over here. Here is flag, right? There's a flag over here. And so she goes straight horizontal. And there's an angle of elevation to the top of the flagpole is 18 degrees. The angle of depression to the bottom of the flagpole, is 14 degrees. So her line of sight is what we're going to call the horizontal. Angle of depression, 14, 15. And so we want to end up finding her distance from the pole if she knows that the flagpole, the whole thing, is 60 feet tall, right? I'm doing some editing. Okay. So let's see. Okay. So let's see. We know some things to be true. I know if this is 18 degrees, I'm going to call this y, and I'm going to call this 60 minus y. Is that cool? So y is just that little bit up there and the amount that would be left over. Or maybe it makes more sense to say, okay, I need to start giving this names. I'm going to call this y, which is from the ground to her line of sight. And then I'm going to give this up here 60 minus y, because that's how much would be left over. If the whole thing is 60, then if this is y, then 60 minus y is left for the top. So this is the picture. Let's see if we can't see the math in the picture. So the math in the picture says that there's a triangle up here where this length is 60 minus y, this is 18 degrees, and this is x. And then over here, this is y, this is 14 degrees, and this is x. So let's just start making some true facts. So both of these are right angles because the flagpole goes straight up and down, and the horizontal goes perpendicular to the flagpole, because that's what horizontals do. So if I have an angle and I have its opposite and its adjacent, so for 18 degrees, this is opposite of 18 degrees, and this is adjacent to it. Well, then that means that if I take opposite divided by adjacent, I have tangent. But in this picture, it's going to be the tangent of 18 degrees is equal to my opposite, which is 60 minus y, over my adjacent, which is x, right? Okay. So that's one true fact that I know. I've gotten that far. Good job. Let's just put a pin in that. Now if I come over here for 14 degrees, this is my opposite, and this is my adjacent. So I have a tangent because I have another opposite over adjacent. And so in this case, we have the tangent of 14 degrees. The opposite is y, and the adjacent is x, right? So notice what I have. I have two equations with both x's and y's in them. So I can solve the system of equations. Let me just stop now. So here are the two things that I know. So I've got that the tangent of 18 degrees is equal to 60 minus y over x. And I've got that the tangent of 14 is equal to y over x. So if I have two equations and two unknowns, you know from a long time ago in Algebra 1 that I can either solve via substitution or elimination. I think in this case I'm going to do substitution. So watch what happens. if I take this thing, I'm going to solve this for x. So I'm going to solve, so I'm going to take this thing, I'm going to solve for x. So solve for x on both of them, actually. So on the one on the left, if I solve for x, if I multiply both sides by x, this cancels out and I get 60 minus y is equal to x tan of 18. But that means that x is equal to 60 minus y over the tangent of 18. Okay? But then over here on the right, if I solve this for x, I'll multiply both sides by x, and I get that y is equal to x times the tangent of 14. That means that x is equal to y over the tangent of 14. So now, what do we have? I have x is equal to this, x is equal to this, and that's just telling you that 60 minus y over tangent. I want to solve for y. So I think what I'm going to do is first I'm going to solve for y and then use that to go back and get x. Right? So let's solve for y. So why wouldn't I just solve for x? Why wouldn't I just solve for y? Oh, so here's what I'm going to do. Sorry. To make my life easier, notice what I can do. Do I have to do it that way? I think the easiest way to explain it to you so that maybe you don't make a mess is I want to solve for what x is because that's that distance. So what I'm going to do is I'm going to substitute. So this one is in terms of x, yes? But notice if I solve this one for y, which I did right here, then I can take it and I can substitute back into the other one. And that's going to give you your cleanest answer. So let's do that. So x is what I want. X is equal to 60 minus y over tangent of 18. Oh, but it's going to have x's in it, so no, I was right. Sorry. No, do what I had. So let's first solve for y, and then we'll go back and solve for x. So since x is equal to this and x is equal to this, let's just set them equal to each other. So that's equal to this, right? And so why is that beautiful? Because then if I multiply both sides by what? Tangent of 14. Tangent of 18. Tangent of 14. Tangent of 18. Notice what that does. It gets rid of the fraction over here and gets me y, tangent of 18. Over here, it gets rid of this denominator and gets me tangent of 14. So I've gotten rid of all the denominators. So now I distribute. I get 60 tan of 14 minus tan of 14y is equal to tan of 18y, right? But remember, I want everything to give me y. So, wow, what happens is 60 tan of 14 is equal to tan of 18, that many y's, plus tan of 14, that many y's. So it turns out that if I factor that out, I get the tangent of 18 plus the tangent of 14, that many y's, right? So then I just divide by that number. So y is equal to 60 tan of 14 divided by tan 18 plus tan 14. Again, make sure everything is degrees, degree mode. So now when you get that in your calculator, you're going to find an answer for y, and then you can just use that to sub back in to this equation right here, and you'll be able to solve for the x that they wanted. Cool. And I'm going to let you do 61 on your own. If there's any questions on it, we will talk about it next time. It's really similar to the one that we just did. Same idea. So these have a system of equations. Again, we said to solve via substitution is the easiest way. Have a great day.